In this video, we shall solve some examples of a functional to be maximum or extremum in a case of variable endpoints along vertical lines x equal to a and x equal to b. We shall take a problem. Among all curves whose endpoints lie on two given vertical lines x equal to a and x equal to b, find the curve for which the functional I y of x equal to integral a to b f of x y dash dx has an extremum. We shall solve this, or we shall prove this. Suppose among all curves whose endpoints lie on two given vertical lines x equal to a and x equal to b be given by y equal to y of x. Let the value of the integral along this curve be I y x equal to integral a to b f of x y dash dx. Consider this as equation 1. Now suppose y equal to y of x plus eta of x. Therefore, y dash becomes y dash of x plus eta dash of x. Be the neighboring path where eta x is differentiable function of x such that eta at a equal to eta at b equal to 0. Therefore, the value of the integral along a varied path is I of yx plus eta x equal to integral a to b f of x y plus eta y dash plus eta dash dx. And this is equation 4. Now, the change in the value of the integral along the varied path is delta I equal to I of y plus eta minus I of y equal to delta I equal to I of y plus eta minus I of y, which is equal to integral a to b f of x y plus eta y dash plus eta dash dx minus integral a to b f of x y dash dx. This can be written as integral a to b f of x y plus eta y dash plus eta dash minus f of x y y dash dx. This is equation 5. Now we shall use a Taylor series expansion. Using Taylor series expansion of the integrand, we get f of x y plus y dash eta plus eta dash y plus eta y dash plus eta dash equal to, we shall expand this term by using Taylor series, and we will get f of x y y dash plus dou f by dou y into eta plus dou f by dou y dash into eta dash plus higher order terms. As eta and eta dash are very small, neglecting the higher order terms, in eta and eta dash, we have the integral 5 becomes delta I equal to, we shall substitute this value in equation 5. We will get a to be f of x y plus eta y dash plus eta dash can be written as f of x y y dash plus dou f by dou y eta plus dou f by dou y dash eta dash minus f of x y y dash dx. Now this can be written as f of x y y dash, f of x y y dash plus minus get cancelled, and we will get delta I equal to integral a to b dou f by dou y eta plus dou f by dou y dash eta dash dx. This can be written as integral a to b dou f by dou y eta dx plus integral from a to b dou f by dou y dash eta dash dx. We shall integrate the second integral. Integrating the second integral by parts, we obtain delta I equal to integral from a to b dou f by dou y eta dx plus, we shall integrate this by parts, and we will get eta x dou f by dou y dash from x equal to a to b, x equal to a to x equal to b, minus integral from a to b d by dx of dou f by dou y dash into derivative of eta dash into eta x, integration of eta dash x is eta x dx. This can be written as delta I equal to integration from a to b dou f by dou y minus d by dx of dou f by dou y dash into eta x dx plus eta x dou f by dou y dash at x equal to b minus eta x dou f by dou y dash at x equal to a. This is equation 6. Here we can see that, note here, unlike the fixed endpoints problem, eta x need no longer vanish. At the points x equal to a and x equal to b, in order that the curve y equal to y of x to be a solution of variable endpoint problem, y must be extremal. And that is, y must be solution of Euler's equation. Thus, for extremal, we have delta I equal to 0. Delta I equal to 0, this implies that dou f by dou y dash at x equal to a must be 0 and dou f by dou y dash at x equal to b must be 0. Thus, to solve the variable endpoint problem, we must first solve a general integral of Euler's equation and then use the condition 7, that is dou f by dou y dash at x equal to a equal to 0 and dou f by dou y dash at x equal to b equal to 0 to determine the values of the arbitrary constant. That means to solve the problems on variable endpoint, we must have to solve the general integral of Euler's equation, and then we use the condition dou f by dou y dash at x equal to a equal to 0, dou f by dou y dash at x equal to b equal to 0, and determine the values of the arbitrary constants, and we can get the solution. Thank you.